there are a variety of tools and accessories that you need to have. Of course, you're going to be using paper towels somewhere along the line. This is a flat-bottomed tamping stick that is used to tamp the raw material properly down inside the vessel. This is a CO2 transfer fitting that you will be using for topping up your CO2 tanks. A series of wrenches. This is an 11 millimeter, 13 millimeter, and two 9/16 wrenches, plus a crescent wrench, which is used for detaching the supply lines and recapture lines from their respective tanks. This is a small digital thermometer that is good for determining the temperature of your freezer antifreeze. These are plugs. These are made from Delrin or nylon, and they're used to fill up voids in your extractor if you don't have a full load. Delrin or nylon. They are inert and do not react with the CO2. So these are recommended for filling up voids in the extractor if you don't have a full load. It's important to use these on top of the load. That's on top of the load, not underneath the load, because these keep the raw material submerged in the carbon dioxide. The high density carbon dioxide is toward the bottom end of the extractor vessel. So you want to keep it down in that high density. You don't want it to float up on top of it. And that's what these do. They keep the raw material from floating on the CO2. Very important if you're using less than a full load. Now, I've built a little stand here, and that keeps everything nice and stable. This is for a 2-ounce unit. The 5-ounce unit has a clamp on it that keeps everything stable. But for the 2-ounce, just to keep everything stable, I basically screw it down to the desk. This is the supply tank heater over here. This is the collector heater. This collector heater runs this heater. This is very, very important because if you don't add heat to the process, dry ice will fill up in here. And so you need to provide heat in order to prevent the buildup from dry ice. Supply tank heater deals with the supply tank over here, as you can see. It's wrapped around the supply tank. It is sitting in the bottom third of the tank itself. The heater needs to be installed where the liquid is. To load the raw material here into the extractor here, we're going to pour a little bit of it in there first, and then we'll tamp it down using this flat-bottomed round tamping rod. The flat bottom is very, very important because we need to have an even tamp down inside the extractor to prevent voids. Voids are empty spaces that allow the CO2 to channel, and we don't want channeling, so we need a nice, evenly compacted bed inside the extractor chamber. But this, we'll call it 1/4 ounce. Then we take our flat bottom stick, and we're going to tamp it down like this, all the way around. Like that, fairly tight pack. Okay, nice and flat and even and flat on the top. Then we add some more raw material. This. Tamp it again. Same thing. Down. Nice and even. Now it looks like it's full, but you'll see when it's tamped down, it's actually quite a bit lower down inside the column. Okay, so we tamp it down like that. And then we brush off the residue on the top. And we can see that there's quite a bit of void in there. And this is where the spacers come in. Remember I talked about these spacers before, these Delrin nylon type spacers. Go in like this. This one's obviously too tall. Okay, so we're going to take a smaller one that we've got because we need a couple of different lengths in order to accommodate different loads. Now you see that this one here is fitting nicely in there. Before you screw the top onto the extractor, you need to lubricate this edge all around here, all the way around with, I use jojoba oil. This is a very good natural lubricant. When you screw on the extractor top, you just screw it down. You'll feel it hit resistance as it hits the O-ring, and then you keep screwing it on until it bottoms out. Once it bottoms out, the seal is made. You do not have to force this any tighter than that. Just screw it down, feel the O-ring resistance, screw it down further until it hits a hard stop, and just leave it alone. This is the top of the collector. Once again, this ring around the top needs to be lubricated with jojoba oil or some kind of lubricant before the lid is attached on. Once it is screwed all the way down, once again you will hit resistance from the O-ring, then you continue on till you hit a hard stop. When you are finished extractions and after you've depressurized the system, you need to loosen this top off. Don't leave it in a tightened state. If you leave it in a tightened state, the extract will act like a glue and make it very difficult to remove the top from the tube. So whenever you're finished, just screw it off and leave it on the top, basically like this, just sort of sitting there loose, so that the O-ring is not compressed and doesn't stick to the tube. We have the supply tank over here. And up on top of the supply tank, we have the pressure gauge. This is ambient room temperature right now, and it's running about 750, just under 800 psi at ambient temperature. This is a 47.5 pound topped up supply tank. So I've got the valve, this valve here shut off so that we can read the pressure from the tank. This tank has got insulation on it, not necessary, but I sometimes put that on. This is the band heater on the tank down below. You can see that it's installed on the lower third of the tank. If this tank was upside down, it would still be installed on the lower third closest to the deck that it's sitting on. We see the supply tank line coming around here, okay, and it goes into this isolation valve that's on top of the extractor, the little extractor. The lid is on the extractor. The extractor is full. You've seen the tamping procedure for that. Again, a little bit of insulation on that. This line here is the line that comes out through the very fine micron level filters in the base of the extractor, comes up here, runs along the line to the solenoid valve. The solenoid valve is what pulses to control the flow rate of CO2 through the system. This solenoid valve is controlled by this timer here that's plugged into the wall. I use a power bar here to centralize all of the electrical stuff. There's basically 3 different plugins required. You see 4 here because the white cord is the freezer temperature. You see 4 here because the white cord is the freezer power. Now, once we get past the solenoid valve, we go into the collection chamber down here. Pulses of saturated CO2 go in here. The sudden expansion of the CO2 that goes in here releases the extract from solution, and the extract falls down to the bottom of the collector. The bottom of the collector has a heater on it. The reason for this is to prevent the formation of large amounts of dry ice in here, because there's a huge amount of heat required in order to keep dry ice from forming, and that's what the heater provides. This is the controller for that heater. And while we're down here, this is the controller for the supply heater. I'm going to show you how this all works in a moment, but I just wanted to show you the flow. So again, coming in through the extractor, up through this valve, down into here, the CO2 that now doesn't have any extract in it goes out this, through this isolation valve, past this pressure gauge. This is a pressure relief valve that you use for depressurizing the system after you're finished, or partially during anywhere in the process you can use that actually. Then it goes into the recapture line. Inside the freezer is where the recapture tank is. This antifreeze is non-toxic plumbing grade antifreeze. It is used typically for winterizing recreational vehicles. When you change the tanks, when you swap these tanks, you're going to shut off this valve, shut off this valve, and then when you use a crescent wrench to loosen this off and depressurize just this joint right here, that's all the CO2 you lose in a tank swap. It's the same on the supply end. You can see here that there's a safety burst disc. This is a 1800 psi burst disc. There are multiple burst discs on this system for safety purposes. There's one here. There's one on the top of the collector as well, right here. And both CO2 tanks have burst discs on them in the back here. Now, these are 3000 psi bursts on the CO2 tanks, but the point being that there are multiple safety devices in these systems. We have slush and we're running around minus 21 Celsius. Anywhere between minus 20 and minus 30 is quite satisfactory, so this is good to go. We're showing about 1300 psi right now. That's a good place to start. Anywhere between 1100 and 1400 or 1300 is a good place. Typically over 1100. If I press this set button and release it, that's the temperature that we're going to go up to. So this extraction will be run at 45 degrees Celsius. Okay, but in order to speed it up and get it heated up quicker, what I will do is I will press the set button again, press these arrow buttons over here, the up arrow button, and hold it down, and it will run up to the maximum temperature of 80 degrees. I will press set. So now I'm applying a lot of heat to this because I'm going to heat it up quicker and build pressure quicker. When you're doing an accelerated heat up and you've got it set at 80 degrees, it's a very good idea and highly recommended that you get a little timer like this. It's a countdown timer, and you wear it on your belt or keep it in your pocket so that it will notify you when a certain amount of time has gone by. This way you won't walk away and forget, because the timer will remind you that you need to check the pressure. When it gets to the pressure that you want, which is typically somewhere between 1100 and 1300 psi, then you're going to go and you're going to hit that button again, the down button this time, hold it down, and it will run down until we get to the temperature that we want, which in this case is 45 degrees. Press set, and you're there. But you only do that once you've got the pressure that you want. Again, between 1100 and 1300 psi typically. Make sure that all your valves are closed. This valve is closed. This extractor isolation valve is closed. The solenoid is closed by default. The collector isolation valve is closed, as you can see here. And this is the pressure relief valve, which needs to be twisted clockwise until it's tight, hand tight, and it's closed as well. So all of the valves are closed up top. Then we're going to go down into the freezer, and we're going to look and make sure that these valves are closed. So this valve, the big valve here with the long handle on it, it's closed, and the recapture tank itself is also closed. We start with all valves closed and all heaters off. We're going to open the recapture tank. Okay. This recapture tank is not completely empty. It is cold. There's probably about 4 or 5 pounds of gaseous CO2 in it. When I open that and this valve is still closed, this part is pressurized. Now I'm going to open this. And when I do that, it pressurizes the recapture hose. So now we have back pressure coming from the tank through the recapture hose and up to the recapture pressure gauge. So we can see that we're running a little bit under 200 psi at this point. Anything under 300 is a good place to start. You note that this valve is closed, so all that's pressurized at this point in time is the recapture line itself. This is closed. The relief valve is closed. Now we're going to start the supply heater. Press reset. That puts the heater in standby mode. It's not on yet, but we're going to press it again, and it is now working. If we want to see what the set temperature is, we just press the set button up top. It's set at 45. That's where we want it to be. Press it again, and now this is running. As soon as we've done that, we want to go over to the collector heater, press reset, put it in standby mode, like that. If we want to check what the target temperature is, we can press the set button. We can see it's 65. That's where we want it to be. Press it again, and it's ready to go, but it's still off right now, and we're going to leave this off for a moment. Now we're going to open this valve and pressurize the supply line. Okay, we've done that. We're going to go down to the extractor, which has no CO2 in it yet because this isolation valve is keeping that from happening. We're going to open this, and you can hear the burst of CO2 as it goes in and fills up the extractor. Now we're going to leave that for maybe a minute or two, and that allows the CO2 in the extractor to become as dense as it's going to be for the extraction. Now that the extractor is pressurized and it's been sitting like that for a couple of minutes, the supply heater is on. We're going to start the process by pressing the reset button again. Now this provides heat to this collector, which is now warming up. And as soon as we have done that, we're going to go over to the timer, which is over here, and we're going to press confirm. Okay, so the entire process has now started. You will note that at this point, this valve is still closed. And we're going to leave that closed for 2 pulses. As soon as you start to confirm, that's 1 pulse. And then after 58 seconds, you're going to have another pulse. Once you've had 2 pulses, then you open this valve. You note that the pressure rises and then falls. After a few minutes, you'll see that the pressure will drop down here to just a little over 1,000 psi. That's fine. If you want to elevate the pressure, you just elevate the temperature by resetting the heater controller. For example, set, run it up to 50 degrees, press set again, and now the extraction will run up to 50 degrees. And I'm actually going to leave it at 50 degrees for this extraction. You can see the heat going up now. As the process runs, the pressure in the recapture tank increases. That's a function of the heat being transferred through the system, and it's completely normal. When the collector heat is on and you hold your hand here, you should be able to feel it be slightly warm, and it will be hotter down the tube, and that is completely normal. If you find that it gets too hot up here, then what you want to do is you want to reduce your temperature down, which I've done. I moved it down from 65 degrees to 60 degrees, and it'll hover around 60 degrees as the heater turns on and off. If you ever find that you get frost on the top here, if it freezes up at the top, that is an indication that your solenoid valve is leaky and needs to be cleaned. Right here, everything is running completely normally. And then I'm going to plug the solenoid valve directly into the wall. Now what will happen is the solenoid valve is remaining open, and the CO2 is flowing directly from the supply tank, the remaining CO2 that is, all the way through the system into the recapture tank. This will minimize the top-up that we have to do, if we have to do it at all. So you always want to get the remaining CO2 out of there before you disconnect everything and do the swap. Full recapture tank is now on the scale. It's showing 48 pounds, 10 ounces. The reason it's higher than the original is because there was some residual CO2 in the empty recapture tank in the freezer in the first place. So this does not need to be topped up. It's ready to go like it is. You can see here that the temperature is about minus 17.5. We started off with about minus 21, so we've lost about 4 degrees. This is still cold enough to run another tank, and that's what we're going to do. This is the former supply tank, which is now being used as a recapture tank. It is sitting in the freezer, and we're going to let this cool for, I don't know, maybe 10 minutes, just to get rid of some of the residual heat that's in there. Now that we've reached 1200 psi, this took about 25 minutes for this to reach this pressure. If you had a standby tank, you wouldn't have to wait this long. You could just put it in, and it would only take maybe 10 minutes in order to do that. Now we've drained the vast majority of the CO2 from the depleted supply tank. We've run it through the system. It's running now around 400 psi, so there's some residual in the tank. We'll weigh that. Over here in the back pressure, we can see that we've got 400 psi back pressure. So now we're going to drain the system and collect the extract. First, turn off this valve here. Then we turn off our tank valve in here, a recapture tank. And now we are going to loosen off this valve here. The system is completely decompressed because we've left the solenoid valve open. We left all the valves open except for the tank valves themselves. We can see here that we're down to 0 as well. The total amount of that CO2 is probably about 1.5 pounds, maybe less. So we shut off the timers. Just hold down the switch. Hold down the switch. Unplug the solenoid. Then we'll disconnect the line We can disconnect it pretty much anywhere we want along here. I will choose to disconnect it here, actually, to take this off. I will disconnect this as well to take the solenoid off, and I'll remove the cap and take a look at the extract. Down at the bottom, you can see the extract. This is a low-grade hemp extraction, so that's largely CBD. This stuff has been prior tested at 35% CBD when it's in its extract form. I will now add a little bit of ethanol to it to loosen it up and pour it out. And there is the extract. There's a little bit of ethanol in there right now. It'll evaporate off, and then I'll be able to gather up the extract and use it for whatever I want to use it for.